My name is Craig Lamparter. I work with Hewlett Packard Enterprise. I'm a Linux system software engineer, and that really just means that I make Linux work on ProLiant. So if you ever have any Linux engineering questions for Hewlett Packard Enterprise as it pertains to ProLiant, go ahead and give me a call. Of course, all my info is here. The slides are all online. Tomas, Biga, and I both submitted security sessions for SUSECON this year. And it was we determined that they were really complementary. Tomas has more of a security overview, or not security, a strategic overview of Linux system security, and I'm going to go into a little more tactical overview of Linux system security. This isn't necessarily a SUSE specific discussion. What we're talking about really applies to all Linux distributions. So Tomas is going to go ahead and start and talk about security strategy, and then I'll follow up when he's done with security tactics. Maybe we'll do some interesting thought experiments or try to hack a system or something fun like that. So, Tomas, is your mic on?
My mic is on, I hope. Can you hear me? Yeah? Okay.
Switch places.
So, yeah, security strategy. It's not about strategy for your company. It's more about our strategy at SUSE. I want to show you our experience with a case study about how we changed our business processes to handle our updates more efficiently, and the updates for so-called, we call it this way, highly visible vulnerabilities like Heartbleed and shell shock, or these brand name stuff, which cause a lot of media hype and so on. And we learned it the hard way, and we have to change. So I hope I have a lot of Star Trek fans here in the room, yeah, and so let me take you on a journey, yeah. So see this old Captain Kirk, yeah. He has seen it all. So he is in space since decades. He fights Klingons, Ferengis, even Borgs, right? Yeah, and he knows them all. He knows the ships. He knows the tactics. He knows how they think. And he has seen it all, and he is old and gray, and he knows everything. So, but what happens when something new comes up? Let's think about the Klingons attack the Earth. Ferengis sell tickets to the Borgs that you can watch the mess, yeah. And the Ferengis also sell all the fleeing humans from the escaping humans from the Earth. They also sell them new homes for very high rates. So imagine this: Klingon ship comes to Earth, green plasma cannons firing, Ferengi selling tickets, Borg cubicle, all the small ships flying around over the space around the Earth. Everyone is escaping and so on, and it's a real mess. So, and then you have this old guy who thought he knows it all, but this one is new, and this is hard for him to comprehend. And so what should he do, right? That's the question. And to not get completely lost in Star Trek universe, let's come back to some real stuff, yeah? For several years, many years in security business, we have seen always the same stuff. Yeah? There's vulnerability, you get maybe information privately before it was released, then you have a rating system like a CVSS, version 2, where you can score it, and then there comes something like, for example, Heartbleed. The CVSS score was relatively low, but customers just go crazy, yeah, because not of the impact, of the technical impact, but because of the media hype and the push and so on, and what else. So luckily, we at SUSE, we were not affected by it, by Heartbleed, because our OpenSSL version was too old. No, not too old. It was stable and mature and like Captain Kirk, right? Correct. And yeah. So what happened? It wasn't the end. So, but when this Heartbleed wave was over, my dear colleague Markus Meister approached me and told me, if this happens again and we were affected, we have to react very fast, yeah, and we have to have the plan. I said, yeah, okay, let's see, maybe we get one of this per year or so, or maybe one every 2 years. And then there came shell shock, and shell shock was really hard for us. We were able to deliver in time, fortunately, but there was a chance to learn a lot inside of SUSE about our processes and how we work. So, yeah, how does the human brain react to new stuff, right? If you have a pattern in your brain and there comes something new, it doesn't fit in, yeah, then you can say, oh, it doesn't matter, you can deny it. Then if you realize, okay, I cannot push it away, then you have to maybe have fear, yeah, and maybe also some panic, yeah, right? So, and what you don't want, of course, is every time these kind of highly visible vulnerabilities appear, something you don't want is every time run around in headless chicken mode, yeah, and be crazy and everything is unplanned and work like hell. So, what you can do, yeah, you can start working over hours, you can start working at the weekend, you can even try to clone yourself, yeah, what else? Yeah, you can work very hard, yeah, but at the end of the day, it's not efficient, right? So you have to think about it and plan ahead. Let me check my cards here. So, yeah, what we did was, we sat down at one point and make an analysis of what happened, for example, during shell shock. About the communication in the company, about who did what when, how long, and so on, the timelines, etc., etc. And then we are looking up bottlenecks and ways to improve. Okay. So, the lessons learned. Yeah, it was really clear for us that we need a plan, an emergency plan. And the first idea was just to be quick. Yeah, so to release updates very fast, so as fast as possible. And what we also realized is that it was very, very hard to identify these kind of highly visible vulnerabilities because you cannot estimate what the press does with it. Yeah, so and you don't have it under control. For example, if there's a security company and they want to do some advertisement for their products or for their research or for the consulting and they have found the vulnerability and they know about it, they prepare everything, Twitter, Facebook, news articles and so on, and then they push a button and it goes out and the world goes crazy and the media goes crazy and you cannot see it or estimate it. You can also not estimate how the people react. So, and that was really hard because you cannot just use a scoring system for vulnerabilities and say, okay, that's above 8, so it must be this kind of vulnerability. It's not the case. It's completely off this kind of things that you can measure. And yeah, the modus operandi right now for the security team at SUSE is better safe than sorry. So if we think and we discuss issues and if you think, yeah, that could be something that can become a highly visible thing, yeah, then we start an internal process early. And if it doesn't happen, then it's okay. Everyone was on rush and was preparing, but maybe it wasn't that dramatic, and then we can just cool down again. But better this way than the other way around, that we are too late, for example. So, what we also realized during shell shock was that the communication, we had too many communication channels. Yeah. So, for example, every function in the company has their own email thread where they do discussions. Yeah. So, the the product managers have discussions, the engineers have discussions, and they do different things for a different time, and it was a bit complex and complicated. So, what we also did was creating one communication channel. Very easy, one mailing list, and everyone who is important and who can decide something, who can execute, is on this mailing list. So, one channel, everyone is there, everyone has the same kind of information at the same time, and there's no big confusion. We also invented something like a coordinator and coordination team around this. That's a change in the meanwhile a bit. And we also try to have SLAs and also server level commitments behind it, just to be fast when it comes for technical reasons like building packages, releasing packages, and so on. Yeah, one thing that we also realized was that facts don't count. So if your customers are in panic, you can tell them, it's not a big deal, it's not a big issue, you're not affected because of this and that, and you're only affected when you use this service and so on. But if the panic was released, yeah, you cannot argue a lot. Yeah, so support gets calls, a lot of calls, many calls. They get support requests and so on, and the level rises very high. And you can only keep it down or calm the customer by releasing a patch. Yeah. There is a waste of time if you start arguing. Don't argue if the customer is in panic. Deliver and make him secure, and then everyone is happy. Yeah. And that's also an important point. So for us, we realized analyzing it very deeply, arguing around it is very good and helpful, but not at the first place. So at the first place should be a patch. So everyone knows applying the patch, and then he's secure. Yeah, as I said, we focus on fast updates, but we also realize then that only releasing fast updates is not enough. So for example, then after releasing the updates, we have requests from customer care, from our support, yeah, saying, I want to write a TID, technical description for this vulnerability. I need this information, and it would be better if they have the information very early, because the customer is asking about it, and if we can just point them to this TID, the customer is happy, and we don't have to explain everything again and again on telephone or via email or so on. That's the reason why we also realized communication was important. We also have people out in the field, support engineers and so on, and they have direct customer contact. And they also need to be prepared. Yeah, what you don't want is that the customer comes to you and tell you the news about your product. Yeah, that's bad. Yeah, you want your guys to tell the customer the news about your product and not the other way around. So that's also the reason why we established the communication plan, for example, with different steps. And we also involved marketing, we involved our customer care, our product management and so on, and all these people work on a cross-functional team and prepare the information that's needed so that everyone is aware ahead of time. So, yeah, I mentioned here business continuity management. For example, if your infrastructure is built with your own products and you have some kind of denial of service or maybe a remote root exploit in your product, you should take care that your stuff is working so that you can deliver an update for your customer. So that, let's say someone is hacking your system with this new highly visible bug and completely disables your infrastructure, then you cannot deliver patches to your customer. That's also some important point there. So it goes completely from communication inside, communication outside, processes, the right people at the right time, at the right spot to communicate, down to infrastructure, right? Yeah. What's also important was that we get a connection to our customer care people that wasn't there before, so that they are aware of this situation and they get the first customer reaction because they get the telephone calls and support requests, and then they can come to us and say, there's a vulnerability and I have about 100 calls in 1 hour about it. You should know about it because this can something like a high visible vulnerability, so that it works also the other way around, that not always we decide about what falls under this category, but also the other way around when support comes and says, hey, listen, here's a high customer impact and please just react fast. Yeah? So far, it worked very well. Yeah, what was also very good was the involvement of the marketing people, and because they know how to communicate this to the outside in simple words, because technical people and security people are very technical people and on a very special field. I think they use description and words that are not always something that a customer can understand always, or people that decide about it can understand it. So That's good that they use another language, and it's also good that they are aware of it and put resources into it. And yeah, so for security reasons and for our customers, it works very well. Okay, so just some schematic a picture here how it should look like. Our marketing guys created some kind of communication plan with the different levels based on impact. And this also includes the creation of a team for this highly visible vulnerability. So at the top we have some steering committee, which is our senior and executive level team, management team, yeah. And it's needed for if there are resource constraints, something very important to decide, maybe something that's outside of the contracts. It has to be decided. It cannot be done by us. It has to be done by higher management. For example, for Shellshock, we also released updates for very old machines that are not supported anymore. We did it once, but this is something that has to be decided by someone else, not by us. But normally they are not that often involved. Just once so far. The other one is, I call it management team. It's everyone in the process that has a role who can decide something and execute something, like people from the security team that know about the security issue and can evaluate it. They are then part of the management team. They are also marketing and customer care people on the team that can write all the articles for the customers and so on. And yeah, on the lower level, then you see all these cross-functional yeah, people or entities or so that are involved. Yeah, customer care, I often mention it, but also releasing updates, normal online updates, but also so-called PTFs, which are just an RPM released for which can be done very fast. So for really critical emergency updates, for example, where we see we are not able to release an update very fast because of quality assurance tests, because of building times and so on, we can also release these kind of PTFs very fast to our customers, which are not tested, but they include the patch. So yeah, the social media stuff and so on, and our the customer center is also involved. So for critical stuff, we also add banners to websites, we add banners to SEC. We release security advisories, of course, and yeah, all the stuff that's needed to reach a customer and to inform him or her, and yeah, that the customer feels we know about it, we work on it, and we take care about his business. Product management is, of course, also involved, not that actively, but sometimes there's something to decide, and they can do it and help us also set priorities and so on. Yeah, and as I said before, a secure and reliable infrastructure below doesn't help if you have good people and good processes and so on, and a good communication if your build service is breaking down or you're not able to upload the patched RPMs. Yeah, it's normally a summary, but I think I cannot tell you something new. I think the important stuff is what we really changed to make it really better is that we have this cross-functional team. Now, this cross-functional team is very, very important, and everyone is aware about this issue. So for our work in the security team, for example, we are always aware of this problem. Even if it's very seldom, we are aware of it, and then you can talk about it and then start the process. And everyone who is involved in this is aware of it and knows what to do and how to handle it. And this cross-functional team is, I think, one of the big advantages. What we also changed was we make our infrastructure or our processes on a technical level much faster, for example. So we have a content delivery network, for example, where we push all the updates to the customers worldwide. And for example, due to this, we were able to increase our speed by 9 times as fast to pushing our updates worldwide, which is very good, very, very good. The other thing is that, you know, you have to be fast, and you also can adjust the processes. It can inform maybe other teams that are involved very early, that they can prepare, for example, quality assurance, that they know, okay, this product is involved, so I have this quality assurance engineer who is a specialist for this product, and I need this and that hardware. And so these QA people can just prepare everything. So, and everyone is on board, everyone knows what to do, everyone knows what's affected by it, which product, what is to test, and there are no surprises. So everyone gets information very early. That's the important point. Yeah, I think that's it.
How are we doing on time?
I was very fast.
How much time do we have left?
We have left, I just take 20 minutes.
Okay, terrific.
Yeah, so.
Any questions for Tomas on
any questions
on this process?
Your presentation sort of described how SUSE reacts to security emergencies that come up. Can you talk about how SUSE is more proactive, like not just reacting to things that come out from outside?
Yeah, of course.
How has the process changed for the legacy
On
code?
the reactive part, so like doing product testing and source code reviews, that's what I understand under proactive part. Yeah, that's something we don't have to change. So we do it already since years. Even the early beginnings of the security team, we were very powerful in doing source code reviews. Yeah, I have to say we have the most secure FTP server in 1998 for years. So on the proactive part, we do source code reviews on security relevant parts of the product. We also do automatic checks that enforce some policies when it comes to policy kit and to dbus, for example. Also the product teams reach out to us and ask for reviews before the product is released, so we can do some testing of the product. Yeah. Any other question? No? Okay.
Thank you, Tomas.
So handing over to Captain Craig from HP.
You know what Tomas does, day to day really may have a big impact on our mutual customers. So Hewlett Packard and SUSE obviously share some very security conscious customers, governments and banks and things like that. So I know when something like Heartbleed comes out, I know SUSE already has a solution, before our customers start complaining to us, because we do try and spread that workload. So we're going to shift gears a little bit. We talked about the security process at SUSE. I want to talk about security tactics a little bit. This is where, how are the hackers attacking your system? What are you going to do about it? How do you know if you're being hacked? How do you know if you've been hacked? They cover the tracks. They're clever. I think one of the best ways to implement your own Linux system security is just to think like a hacker. Try and hack into your own system, or hack into your friend's system. Tell them to hack into yours, right? Do some penetration testing, get creative. So I've got a Linux laptop right here. And I shouldn't even say it's Linux. I've got a laptop right here. Let's say I will give 100 euros to the first person who can give me a root prompt on this laptop. I said euros. Last time I gave this presentation was in Europe, so I don't know what the exchange rate is. I'll give you the same offer, $118 US for the first person to give me a root prompt on this laptop. But where would you begin? Where would you even start? What do you know about this laptop? Anything? Do you have physical access or not? Yeah, well, I could probably stop you. I mean, I'm not that fast, but I could probably get to you before you got to the laptop. Physical access, that's a fantastic one. If I can touch it, I own the data, unless there's some complex LUKS encryption or something like that. That's a good one. In fact, I haven't heard that one yet. I like that. What's another way? How would you begin to give me a root prompt on this laptop? Yeah. All right, so you need the IP address. So you're going to attack it from the network if we're not going to take the physical approach. Yeah, well, I'm already giving away one of the approaches here. So, you know, when I ask this question, a lot of people will come up with the social engineering aspect too. Well, I'll just call someone and say, hey, Craig forgot his root password. It's critical that we get this thing back online, and do some social engineering. Just make a phone call. The low-tech solutions are the most effective ways to compromise systems. But we're here, this is a technical conference. We're not going to be talking about social science here, but just be aware that the social engineering is a very effective way to attack a system. And the hackers are doing that. They're making those calls. They're calling companies and asking for, you know, technical information and passwords. But if you're on the network and this is a remote system, you don't have physical access to it, you know, no one's going to give you your password. The first thing you would like to do if we're going to hack into this laptop or any system is to figure out what operating system it's running, right? There's a lot of rootkits out there that are designed to exploit known vulnerabilities in existing operating systems. It could be your favorite Linux distribution, maybe an old version of Windows. Generally, they're targeting unpatched servers. If you go out on Tor and dark web and things like that, you're going to find these rootkits. They're very easy to run and install, and you just give them an IP address range, and they'll go out and they'll hack systems for you. So you're up against automated hackers, not just clever guys in basements. So if I was a hacker and I was trying to get my $118 for giving Craig his root prompt on his own laptop, the first thing I would do is I would port scan the system to determine what ports are open on the system. If you can see what ports are open on the system, it'll give you a pretty good idea as to what kind of operating system is there. You know, Windows has Windows ports, Unix has Unix types of ports. It's good to note that every port below 1024 and below actually has a root process behind it. So only root is allowed to respond to TCP network requests on port 1024 and below. So these are important ports to exploit if you're a hacker. And likewise, if you're trying to defend the system, make sure you don't have many processes hanging off of the low ports which require root. Ideally, you want to be a black hole, and you don't even want to show up on the network at all from a remote perspective. You don't want it to respond to pings. You don't want it to respond to any unnecessary ports. If you do leave something that has some sort of authentication, open authentication mechanism that's not shared key or something like that, SSH, FTP, I guarantee you, as soon as you put a system on the internet, you'll start getting hits on your SSH 22 and FTP ports where people trying to brute force passwords on your system. I guarantee it. If you manage systems on hostile networks, go look in your logs. They're full of those brute force attacks. And it happens within minutes sometimes because these hackers are using automated rootkits spanning IP address ranges, trying to acquire root access on your system or administrator access, let's say if you're using Windows. What does Mac use? I'm not a Mac person. Do they have an administrator user? I don't know. I'm sure Macs are just as valuable targets. Aside from brute forcing basic authentication stuff, there's stuff like application security that you need to be aware of. SQL injection, you need to sanitize your inputs. So let's say you're the best Linux system administrator in the world. You've got this perfect Linux system installed, and then you give it to the application team to install their application, and they just completely foil your security strategy. So make sure you follow up with your security, make sure your applications are secure as well. Tomas, maybe give me another click. All right, so here's an example of running nmap -o. The -o means give me an OS fingerprint. Tell me what OS is on this system so I can download the right rootkit and start exploiting and try and exploit the known problems with that particular operating system. So let's figure out what OS is running here. Can anyone tell me what OS I run nmap -o to my Raspberry Pi at home? This is the host name right here. So nmap -o to my Raspberry Pi, and this is the output. Anyone familiar with nmap can tell me what OS might be running on my Raspberry Pi? It could be Windows. Now, Microsoft just made Windows for Raspberry Pi, right? Some version of Linux. Why? How do you know it's some version of Linux? Oh, yeah, you guys spotted it. I was going to mention this one last. Here's a clue. This is the TCP fingerprint. This is the extra data that's in TCP headers when they come back. So I'll send a packet out and also get like a SYN packet back or an ACK back. And we'll see these values in the headers. And this Raspberry Pi actually announces itself that, yeah, this packet came from a 64-bit PC Linux GNU operating system. What's interesting is the Raspberry Pi is in fact 32-bit, so that's not entirely accurate. So maybe that would confuse a hacker. I don't know. But yeah, it does make the system somewhat vulnerable that it did respond that it was a PC GNU Linux operating system. The things that I typically look for are which ports are open. This is what hackers are going to be looking for. These are your doorbells. They're going to ring these as many times as it takes until one of these doors opens for them, right? There's only 3 ports open on this Raspberry Pi, which is great. I've locked this down. Normally when you install them with everything, all the ports are open. You've got MySQL, Ingress, all kinds of crazy stuff. And they're responding on these low ports too, below 1024. Those are the good ones to get because we know something with root is responding to those ports. So on this system, we've got SSH port is open. That way I can SSH into my Raspberry Pi when I'm at places like SUSECON here in Washington, D.C. Windows doesn't really implement SSH, so I can probably rule out that this isn't a Windows system. This is some sort of Unix system, right? That's why we've got SSH there. HTTP, this is a web server of some sort. We don't know which one. We could figure that out by looking at HTTP headers as it comes back. Of course, in this case, it would come back as Apache if we wanted to go there. Or it could be coming back as IIS or something like that, right? So we know there's a web server there. That could be Windows or Linux or Mac. We don't know. It could be anything, right? It could be an appliance. RPC bind is, actually that's common for systems that have NFS enabled, right? And again, another clue that this is a Linux operating system. We don't know exactly which one, but let's just go ahead. We'll get all the rootkits for the Linux operating systems that we know and start pounding on this system until we have root access. So hopefully these protocols have been secured. So what OS is running here? It's some form of Linux, right? It's not Windows. It's probably not Mac. Tomas, give me another slide, please. Does the Mac, any network experts here, does the MAC address come back in my ACK packet when I send a TCP connection request? Do I get a MAC? Yeah, you do, even off subnet, right? You get the MAC address in the header? Yeah, okay. Because I wasn't sure at the ARP level, I know you get the MAC addresses. Yeah, so you could at least figure out who the manufacturer was for the NIC by looking at the first 3 bytes of the MAC address, and it would be Broadcom or Emulux or something. It doesn't necessarily tell me what operating system's on there, which is really what I'm after. Yeah, maybe you could say, well, maybe this is a ProLiant and maybe it's running Linux. I don't know. Yeah, maybe we'll look at maybe hackers are looking at MAC addresses. That's a perfectly valid point.
A lot of networking parts are Linux and utility system. So this is Cisco.
Ah, excellent. Yeah, maybe you hit a router or something. You don't know. Maybe you hit a Cisco router. That would be a good target too. I mean, I'm a lowbrow hacker. I'll hack anything. I don't care. I don't have to hack a router or. Say again? IP what service? Oh, NFS. Yeah, a router wouldn't be running NFS, right? So we saw RPC bind there and things like that. Another important command, again, you're getting the 1-hour Linux security thing, So if you know anything about Linux security, take what you take in this 1 hour and go with it. What you really should do is get many hours of security training. This is just the basics. So and the next command that you should always remember is the netstat minus npvat command. Go ahead and run that as root. You need to run it as root so you can get the process IDs. And look for the lines that have listen in them in uppercase. So this is the ports that my system, my Raspberry Pi, is listening to. These are the ports here. We ignore the 126, the localhost address here on 53 because that's not externally addressable. So we're looking at stuff that has all zeros in it. This is the port number that's externally available. And this is the process that's listening on that port, right? And hopefully these are legitimate processes that you know about, that you've established. Sometimes you'll run this and you'll see some mysterious process. You've already been rooted, and you've already got something listening on a port that only root can listen to. You'll see like something like, they won't say rootkit, it'll say something like system X or something like that, something clever, something that looks benign, but you need to be aware of these are the processes that are listening on these ports. All right, and these are IPv6 addresses, that's why you don't see these here, but put all of these ports together, and these are the ones that your system is responding to using these processes. Netstat minus npvat, that's a great one. What is your system listening on? And reduce these number of ports if you can. Tomas, if you could, please. Thank you. All right, so we did a little bit of hardening here, just real basic hardening that anyone can do, right? It's really simple. You're not going to damage your system by locking out ports that you know you don't want to use. So how do you know if you're being attacked? Maybe there's an attack in process. Like I said earlier, if you've got a system on the internet or any hostile network for that matter, I guarantee they're trying to hack it right now. Packets are coming in, they're running nmap, they're seeing what ports are open, and they're finding authenticated ports where they can maybe brute force an attack. So here's an example of attack in progress. This is on an actual HPE server that's on a hostile network. We expect them. There's no reason to panic or anything. This is just someone running a dictionary against SSH. It's not always obvious to know where this stuff is logged. In fact, this is in auth.log, and not all systems have auth.log. It's part of the syslog facility. So auth.log, messages, and syslog are the best places to look for applications complaining about unauthorized or unauthenticated attempts on their ports. In fact, I didn't even know auth.log was a thing until I was sitting in my office, and my computer room's quiet. I like it that way. I was sitting there working along, but every 8 seconds my hard drive would tick. This is back when we had rotational media and your hard drive would tick. Every 8 seconds it would tick. And so if someone, OCD like myself, that bothers me. Why is my hard drive, what is writing to my hard drive every 8 seconds? I'm just sitting here reading something useless on /dot, right? So I go into messages and I says, what is writing to the file system? And, well, there's nothing happening in messages. I go into syslog. Well, there's really nothing happening in syslog. Why? What process is writing to the disk? I ended up using iostat, the file system tools to say, oh, this process is writing to this file, and we're flushing the buffers every 8 seconds. That's why my hard drive is ticking. Well, it turns out the process that was writing to my disk was SSHD. It was writing to a file called auth.log, and every 8 seconds, a hacker was trying a new password to root my system. This is SSH responding. Even when it gets an invalid login, this is the hacker's IP address right here, and then it says thank you for playing, because it knows you're trying to hack it. Even SSHD knows that this is probably a hacking attempt. You can use the whois command to see who is attacking you. So now we know an attack's in progress. They're doing one failed password after another. They'll try tens of thousands, if not millions of passwords against your system, and you won't know it unless you're looking at auth.log, or you have a quiet office like me and you hear your hard drive tick every 8 seconds, knowing that they're trying passwords. You can use the whois command to see who owns this IP address. Most often they're Russian or Chinese IP addresses. If you don't do business with these nations, go ahead and use your firewall to block out entire nations, like the entire country of China can't access my Raspberry Pi. If it's well, this is SSHD complaining that this IP address just sent it a failed password for the root user on my system. That's all this log tells me. That's all I really know. I don't know what the nature of the system is attacking me. Maybe I could do a counterattack. You don't do a counterattack. And the reason you don't do a counterattack is because this system is another compromised system. I bet you it's another. So that's probably why they're all coming from China and Russia, because people hack into these Chinese and Russian systems because they have no security whatsoever. They walk right in and then enslave that system and use that system to start sending tens of millions of passwords at my host until they get lucky and hack my system. So the whois command will tell you who is hacking your system, or who at least owns the system that's hacking your system, even though they're probably not the ones in direct control of it anymore. Tomas, if you could, please. All right, so that's how you know if an attack's in process. Just look at your logs or listen to your hard drives in my case. So how do you prevent attacks? That's kind of why we're here, right? Tomas has a really good strategy on how to organize your business, how to, when a new vulnerability is there, to make sure that the hackers don't get the latest rootkit and instantly compromise your system. At the tactical level, how do you prevent attacks? Active countermeasures are really one of the best things that I've been able to use here, and this is like an adaptive firewall. There's programs out there. One of my favorite is called Fail2Ban. Fail2Ban. I don't know if it's part of the SUSE distribution or not. Is it in there? Yeah, because I remember I was able to get it on Ubuntu or get the RPM off RPM find. I think that's how I acquired it last time for SUSE. So Fail2Ban. So Fail2Ban is really cool in the fact that it's the thing that watches your auth.log for hacking attempts. It not only watches auth.log, it looks at your Apache logs, it looks at your FTP logs, any service that has some sort of a username and password pair authentication request, and it will look for multiple failed attempts. And you can decide that if someone connects to SSHD and gives it 10 failed passwords in a row over, say, 10 minutes, the fail2ban program will actually enter a line in your firewall that instantly ices that hacker IP address. So if someone on this system, with me using fail2ban, enters the wrong SSH password 20 times in a row, some people make it 3 times, but I enter my password incorrectly 3 times. So make it like 20 times. I lock my own. Don't lock yourself out of your system. This will do that. So it wins. It basically all packets from that attacker IP address will be dropped with this IP table's firewall rule that was added by fail2ban because someone did so many failed attempts over a certain amount of time, right? So after 20 attempts, suddenly the system is as if it was turned off from the hacker's perspective. All packets are dropped on the floor. Now you could use reject here as a firewall status. Don't use reject. There's a difference between reject and drop. Drop means when the packet comes in, don't even touch, just drop it on the floor, right? There's no rejection process. There's no packet that goes back. A reject status in the firewall says, look, you're not allowed to talk to this port, but yeah, I'm still a server and I'm still on. You just want to become a black hole. Information goes in, but nothing comes out. So that's what the drop rule is for the IP tables rule. So fail2ban is the point of this slide. I use it all the time. There's usually 20 to 30 IP addresses in my firewall and in all my external servers for this. I expire these after about 48 hours. Otherwise, you'd have millions, not millions, hundreds, if not thousands of IP addresses in your firewall rules, and that's going to slow down your system. You can't have a firewall that big. So expire these rules, and fail2ban will, after 48 hours, expire this firewall rule and start letting packets back in from that IP address. You'll find that they never come back. After 48 hours, they just think your system's off, and the hacking tools move on to the next IP address in their scanning range. Tomas, if you could. All right, so again, on how do you know if you've been hacked already? That's an important thing. What if you walk up to a system and there could be a rootkit on it right now responding, and it could be, what was the last big denial of service attack? I don't remember. It was the core DNS servers that were being DOSed. Well, that's because hackers had controlled hundreds, if not millions of systems, and they're all sending traffic to a single host, basically saturating that host network and downing that host. They weren't just using Linux systems. They're using thermostats, smart refrigerators, things like that, where you can't do this level of, intrusion detection. Okay, so how do you know if you've been hacked already? Talk about rootkits, right? So what does a rootkit do? A rootkit exploits a vulnerability on your system and then installs itself, kind of like a virus. And like a virus, some rootkits will start probing other systems on your network once they're installed on your system, once it's been compromised. Rootkits don't like to be detected. They'll modify your system to make sure you can't detect that there's a rootkit there. Sure, you can run the PS command. All the normal processes there. But what you might find is the PS command isn't the PS command that you installed in the system. It's the PS command installed by the rootkit. And that PS command doesn't show you the process for the rootkit that's running on your system right now. They'll even modify the ls command. If you do an ls in your root directory, you see temp etc/root. If you're using an unmodified ls command, you might see where the rootkit's installed. You'll see a directory called, well, let's just call it rootkit. They won't call it a rootkit because that's too obvious. They'll call it systemx or something, right? They'll modify the ls command, so when you do an ls, you won't see the directory in which the rootkit's installed. I was doing a post-mortem on a friend's system, and it's not commonly known, but most Linux systems have the dir command, dir, for people who can't get off DOS, right? They're using a Linux prompt. Well, this particular rootkit forgot to modify the dir command, so I would do an ls in the root directory, and I wouldn't see anything. It would look completely normal. I'd do a dir in the root directory, and there's the folder with the rootkit in it. So that's actually how we found it, doing a post-mortem there. So the command here, the takeaway is the rpm-va command on SUSE. This will go through your entire RPM database and look for files that have been modified since they were installed. This will find you the rootkit immediately, unless they've modified your RPM database. Right? They're clever. They're smart. They're smart. They're unethical, but they're very smart. If they've modified your RPM database, there's other tools like Tripwire that comes into play, where you can actually store signatures remotely for all of your files, and come back and say, hey, look, all of these files have been modified. I know that for a fact because everything's been signed by Tripwire and stored offsite and things like that. Well, I know we're not talking about Debian here, but Debian has a a similar way to validate files that were installed from their packages by their checksum. So this is how we detect rootkits that are there. Unfortunately, most people find out they have a rootkit installed in their system because people start calling them and say, "Why are you hacking my system?" Right? Because fail to ban has their IP address now. So you don't want to receive that phone call, right? You want to detect a rootkit if it's already been installed before someone else on the internet starts being hacked by your system. Tomas, how are we doing on time, Tomas? I have no phone or watch on me. 15. Okay, we're doing great on time. This is kind of a summary for tactical security or prevention specifically. We talked about documented security policy, validate implementation with audits. That's really a lot of what Tomas was talking about earlier, right? Have a process for security. I don't care what it is. Just have a process, even if it's, just checking for CVE vulnerabilities every other day or something like that. Have something and stick to it. Don't modify it. I didn't mention Tiger yet. Tiger is a tool that you can run on your system. Tiger will look for like SUID execute bits set on files that shouldn't be set. It'll look for permission problems on your systems. It'll look for open ports. It'll look for general things that, well, hackers would be looking for. So Tiger is a good way to audit your system to see if it matches some sort of compliance. In fact, you can add modules if you've got a security policy in your business or organization that says the temp directory needs to have 700 permissions on all systems. The Tiger will actually check that, and you get a nice report at the end to see what the Tiger report is for a system to see if it passes some sort of minimum security criteria. UEFI Secure Boot's a new thing. How many people are using Secure Boot? Besides me. It's not as evil as, I know Microsoft's kind of started it. It's not as evil as it sounds, you guys, right? It's just kernel code signing. It's been around in the kernel forever. I think for at least 10 years, kernel code signing's been in there. UEFI Secure Boot just extends Linux kernel code signing all the way to the hardware. So the certificate of trust is in your hardware and cannot be modified unless you're physically present at the host. So look into Secure Boot if you don't want someone modifying your kernel. That's a great place for a rootkit also, is to be a kernel module or be in the monolithic kernel. That'd be really hard to detect if you were a rootkit in the system kernel. SELinux, is anyone using SELinux? All right, we got a security guy here. SELinux is hardcore security, right? SELinux is, you can activate it on your SUSE system. We could do a whole presentation on SELinux, so I'm not going to go too deep into it, but in essence, it's about mandatory access control. So if I install Apache Server, I expect it to be able to see a file it has read-write permissions like the HTML docs directory, right? Well, if SELinux is enabled, Apache can't read its index.html file because you haven't explicitly said that this process is allowed to read that HTML file. So that's to the extent SELinux works in its enforcing policy mode. So SELinux is really something for governments and banks and things like that. You could build a whole career around setting up SELinux for systems. As far as policy is concerned, usability and security tends to vary inversely. So highly secure systems are not very user-friendly or usable. Use some common sense here. My guiding principle is that the cost of security really should not exceed the value of the data you're trying to protect. Every security architect in here is probably disagreeing with me, but that's just a guiding principle. So think about that. I mean, really, if you want to take it to an extreme, you could just turn the system off. There, that's the most secure system in the world, but it's not usable, right? So security and usability vary inversely, in my experience. We talked about active countermeasures, systems that are going to adapt to attacks using fail to ban. The IP tables firewall is probably the single most important security feature that's in the Linux kernel today. It used to be called IP chains. This is how you reduce the number of ports that are available on your NICs and who can access what and from where. The IP tables firewall. All right, Tomas, one more. Let's see what we got here. I know I mentioned application security, but hey, I got a whole nother slide here that says don't forget application security. Even once you've got the fail to ban installed, you're passing all of your security audits, your firewall's great, you got a minimum number of ports. The guys come in and install Oracle, and then the Oracle rootkit just comes right in and your system's compromised. So Do not forget application security. Go ahead and make that part of your audit as well, because I know a lot of organizations will have an application team and a system management team, and the application team usually isn't security conscious like the system management team traditionally is. All right, a few more minutes. All right, this is going on about application security again. XKCD. You know, this is where the mother gets a call from the school. You know, we're having some computer trouble. You know, did your son do something? And they, well, yeah, in a way. Did you really name your son Robert semicolon drop table student semicolon? You know, that's obviously they didn't sanitize their inputs. Her son, the hacker, knew that and was able to inject SQL commands into a field on the school's webpage, right? Of course, she covers up, says, oh yes, little Bobby tables, that's what we call him, right? Trying to cover up for her hacker, nefarious son. So again, sanitize those inputs from an application level. So you don't have people dropping tables by putting the drop command in their name where they're in the field where their name normally would go. Application security. Tomas, one more, please. This is a slide I usually look at if I have a few more minutes left in this presentation. I know I'm talking really fast here, but that's because Thomas and I are collaborating with a lot of the security information. So IP tables. Who's familiar with IP tables? Yeah, awesome. So lots of people. So like I said before, this is probably the single best tool you can use on your Linux system to minimize the connection attempts from people that you don't care about or don't want accessing your system. I'm not going to go into great detail because most of you opened your hands here. Research IP tables if you haven't already. The important thing, at least I thought was weird, this is a top-down kind of thing. So a packet comes in at the top and passes through all these filters. And at some point the filter either accepts the packet or rejects the packet. And you get to decide how these filters work, and they do work in order. This is a very simple IP tables file. This is about as simple as it gets. They get really complex. You know, I'd advise doing something more simple. That way other people can read it. You want to make sure packets aren't getting through that shouldn't by just using a simple IP tables firewall rule set, which is what this is. So this is my Raspberry Pi again. You guys are all going to hack my Raspberry Pi. I probably already disclosed it. So if you hack my Raspberry Pi, well, I owe you 100 euros, right? If you get into my Raspberry Pi by looking at all these examples. But you shouldn't be able to get in there, right? Because we're using all of these cool security features. So a packet comes in here. This is my local subnet. If it comes in on my local subnet on the input chain, I accept it. I figure if you're in my house, you have physical access to it anyway. You can probably get in there, right? So this is my home subnet, right? We're not going to talk about the block chain until the end here, but we're just going to define a chain called block. Again, we got packets coming in on the input chain, and this section here is where I open or close ports. This is like the most important section. So I open port 22 for these IP addresses or IP address ranges, these subnets. So, you know, I want to be able to get to this system from HP. You know, I'm on HP networks quite a bit, so this is the network 15 and network 16. Hewlett Packard Enterprise owns both of those networks. So I can get in from networks in 15 and 16 to my Raspberry Pi on port 22 using, well, 22 is SSH. And of course, anyone can get in on port 80, right? I don't have an address mask for anyone getting in on port 80. Yeah, port 80 would be a good one for you guys to try, because you know you can't get in on SSH unless you're on one of these subnets, right? My system will drop those packets. So 80 would be a good one to try to hack into my Raspberry Pi, because that's open everywhere. This is one system that actually didn't mask off all of China, right? Because that's, or Russia. You know, you can look online to figure out what China's subnet mask is. It exists. You know, there's some ranges that those countries use. This is just some ICMP ping stuff. Sometimes I want to ping the system to see, you know, what the hell happened to it. We talked about block. Now, so far the packet's made it all the way down here, and it hasn't either been rejected or accepted. So let's send all of everything on the input to the block chain, which was defined up here. This is a new chain called block. And this is where we get network address translation, NAT. You guys familiar with that? NAT's really cool. It's basically how every home Wi-Fi router works. So if I send a packet out to a system on port 80 and it comes back on a high port, that packet is tagged and tracked as related to my request. So any traffic that goes out and then comes back in as a response is either related or established. So an established socket connection that I've already established or related traffic coming back, those are allowed back in. I know that sounds really complicated, but that's the essence of network address translation. That's why I can go out to a website, I can go out to /dot, and the /dot page will come back to my system. It will get through my firewall because of the established and related network address translation line in IP tables. And if it doesn't make it past any of this, this is actually the last test right here. The packet's dropped on the floor. Not rejected, but dropped. And there is a difference, right? So drop just means it's like the port was never, like the system's turned off. That's what drop means. Excellent. A couple minutes left. I was so worried we're gonna run out of time here. I think that was the last slide. Go, Thomas, if you could advance it one more for me. Yes, it was. So any questions for Tomas Abiga, or did I get your name right that time, right? Or myself. So Thomas is a SUSE security expert, and I'm Hewlett Packard Enterprise Linux guy. Any questions? All of your systems are secure? Are any of you thinking right now, what systems do I have on that are being attacked right now? It's okay. I'll keep you up tonight. You've got systems in South Africa, right? Well, I guarantee you they're under attack if they're on the internet or in any hostile network. But with just this little bit of stuff and strategies that Tomas put together for managing vulnerabilities, especially with SUSE Linux, we never have security problems with SUSE Linux. You know, we always have to beg the other guy, look, you know, your system's vulnerable, and we've got customers complain. That never happens with SUSE, right? We've always got patches immediately. No other questions? Thank you very much. I really appreciate your attention.